everybody. In this video, we're going to be looking at a very special parallelogram called a rhombus. Rhombi is the plural. So if you compare a rhombus to a parallelogram, I've got our drawing from last lesson. A parallelogram is long and skinny and slanted, whereas a rhombus is much more square-ish, but still slanted, okay? So that might be the most visual change between a rhombus and a parallelogram, but let's see what happens in the numbers. Now, I'm not going to go as slowly through all these measurements as I did last time. I'll probably pause the video a lot and ask you to do the measurements, and you can check along with me, because I think if you're good with your tools here, this will go much faster. But I'll get started. And again, I'm going to start with the side measurements using a ruler. I'm going to use the centimeter side. Okay. So first things first, let me measure my outside, these bolded lines. All right. From A to B, it looks like about 6.6 centimeters. Okay. Just like with our parallelograms, a rhombus has opposite sides that are a match. So we've got another 6.6 centimeters from DC. And then what you're going to notice is that going along with this pattern, from A to D is also 6.6. And B to C is also 6.6. So I have a lot of students who say, hey, that's just like a square. A square has all sides equal. We've known that for a long time. Way, way, way back in the day, you learned about a square, and that's true. This might just be a squished over square, if you want to think of it that way. So all of the outside pieces are all 6.6 degrees, centimeters, excuse me. All right, let's check out the diagonals, A to C. From A to C, ooh, how convenient. It's spot on at 8, right at 8. So from A to C is 8 centimeters. All right, how about B to D? B to D looks like maybe 10.4 centimeters. Now, I'm not using my ruler to do these other pieces. Let's think about what we learned in parallelograms. Okay, with parallelograms, we know that E is a midpoint. So that's true here too. If E is a midpoint and A to C is 8, then E's job is to cut that in half and make 4 and 4. So A to E should be 4 centimeters and E to C should be 4 centimeters. If you want to pause the video to confirm that so you have a visual, do that. Okay. Next, we can do the same thing for our other diagonal. It's B to D was 10.4. So if you take 10.4, cut it in half, you're going to get 5.2 and 5.2 for both sides. Okay, we can check it. If you believe the ruler, that's handy. So there's that 5.2 right at E. All right, let me zoom out just a little so you can see what I'm writing there. Okay, now, something really cool when we start talking about the angles of the parallelogram. That's it about, of the rhombus. Something really cool is happening here. The first angles I'm asking you to look at are the angles at AEB. AEB, so right here. You're going to find, when you check with that protractor, that AEB is a perfect 90-degree angle. You may need a ruler to extend your measure for you. AEB, if I just line it up. If you've had trouble with the protractor, come see me. We gotta be able to use this tool to get all our measures. But if we extended that diagonal on through, it's going to cut perfectly at 90 degrees. So AEB is a 90-degree angle, and that is going to be super important as we move forward. Now, if this is a 90-degree angle, let's not grab the protractor. Let's think about our angle pairs. I know my vertical angle is a 90-degree angle. That's CED. I also know that the linear pair is going to be another 90-degree angle. So all the angles that surround E are 90 degrees. It's a perfect perpendicular connection. Well, guys, I hope you see something here. That means you have a whole bunch of right triangles. And what are some things you could do with right triangles? You might want to jot this down. Because of all of the right triangles in the picture, you could do Pythagorean theorem work, or you might have to use some SOHCAHTOA, right triangle trig. Now, if you have skipped Pythagorean theorem or SOHCAHTOA, you need to stop right where you are and backtrack, because you're not going to be able to hang, I don't think. Okay, we can check out the Pythagorean theorem piece. We've got all our measurements here, and I guarantee it'll work. A squared, B squared, C squared. Plug your numbers in. If it doesn't come out perfectly, it's because we're not perfect measurers. But A squared, B squared, and C squared should work. Let's check it. A squared, that would be the CE, that would be 4 squared, plus B squared, EB, is 5.2 squared, equals C squared, which is the hypotenuse, 6.6 squared. Let's check. Let's see how great of measurers we are. All right. 4 times 4 is 16. 5.2 times 5.2. 5.2 times 5.2 is 27.04. 6.6 squared is 43.56. So let's see how close we were. 16 and 27.04. So we've got 43.04 is equal to 43.56. That's pretty close. That's pretty close. We must not be perfect ruler measurers. Maybe this was like 5.15 and we got 5.2. But this is pretty close. We absolutely could use Pythagorean theorem to find one of the missing pieces if we've measured 2 of them. So keep that in mind. That's going to be a really big deal with rhombuses. You're going to see that a lot. All right, next, let's get some other angle measures. We've got angle EAB. EAB is up here, this upper portion. All right, grab a protractor, measure it upside down here, line it up flush, get the center right on the vertex, and measure. EAB, my options are like 52 or 128. Look at the size. That's an acute angle, so I'm going to go with 52. Now, that is the last measurement I'm going to have to make, everybody, because let's think about this. Alternate interiors mean that this 52 can travel here to ECD. Triangle sum theorem says that the 3 angles of a triangle, let me highlight this triangle, 3 angles of a triangle have to add up to 180 degrees. So I already know 2 of them. I know I've got 52 degrees, and 90 degrees. Well, 52 and 90, let's do this here. 180, take away that 90, take away that 52, leaves me with 38 in this corner spot. That is angle ABE. Okay, use your alternate interior again. 38, upper part of the triangle, flips down to the lower part. That is angle EDC. Another 38-degree angle. Remember, everything should have a pair. Now, look closely. You have two congruent triangles. I'll highlight them both in green. Both these triangles are congruent. They have the same side measures. They have the same angle measures. They are congruent triangles. In fact, you have 4 congruent triangles. Remember, think through that SAS or SSS set of triangles. A to E is 4. That measure here was 4. This measure was 4 down below. We had a couple 5.2s. We have, let's go with this pattern. This side that's 4, this angle that's 52, this side that's 6.6. There's your SAS. If we're going for the yellow triangle, it's SSS. 4, 5.2, 6.6. 4, 5.2, 6.6. Everything is equal. There are 4 congruent triangles here. So 38 is a reflection here. 52 is a reflection here. And it reflects this direction also. Now we were able to do that with just measuring one angle. Everything else fell into place due to this right angle in the center. That right angle makes each diagonal a line of reflection. Let's draw in this line of symmetry here. We could fold up this shape across the diagonal. A and E would match each other. The two 38s would match. Two 52s would match. It's a perfect line to slice this rhombus down the middle. You could also do it going this way. So that's another important note to write down. Diagonals are lines of symmetry. So many cool things are happening right now. Once you start putting the whole shape together, we're revisiting so many things from previous lessons. Let's fill in the rest of our measures here. 52 and 52 combine for a total of 104. Same as down here in this obtuse angle. 38 plus 38 combines for a total of 76. Same as this acute angle. 76 and 104 add up to 180 degrees. That's because the lines are parallel. So much cool stuff. I'm nerding out here. Let's check out the rest of these angles to fill in our sheet. Angle EAD, E to A to D, 52 degrees. Angle EBC, E to B to C, 38 degrees. ECB, E to C to B, 52 degrees. And E to D to A, E to D to A, 38 degrees. I know when I started, I said I wasn't going to explain it all the way through, but sorry, your nerdy math teacher had a ton of fun with that one. Now, we've talked about this rhombus. Let's pick out the truths that we can highlight here about every rhombus. This is just one example. Even if we changed the measurements but kept it a rhombus, This would always happen. So let's start right here. Are both pairs of opposite sides parallel? Indeed they are. Both pair. Not only one pair. Both pair. Both pair of opposite sides are congruent. Indeed. In fact, all four are congruent this time. Both pairs of opposite angles congruent. Yep, we got our 76 and our 76. Got our 104 and our 104. That's a yes. Not only one pair. Now, not all four are congruent to each other. Can't choose that one. Diagonals are congruent? Nope. One short, one long. That's why it's slanted. Long, short. Diagonals bisect each other. That's a yes. E is a midpoint. Diagonals are perpendicular. That's a yes this time, and that's a big deal with rhombuses. That's where the right triangle comes from. That's where the line of symmetry comes from. That one's super important. And diagonals bisect the angles of the figure. That's a yes. This 104 got sliced into two 52s. This 76 got sliced into two 38s. So that's a yes. That's where the line of symmetry comes from. So a rhombus is a little bit more detailed than a parallelogram. Got two things in addition to the pieces of the parallelogram. These four are something we just practiced with parallelograms. Now we're adding these two extra pieces on. Let's get some practice. What does the SOL want us to be able to do? Let's take a peek. Well, we're going to start with algebra. What value of x would assure that parallelogram ABCD was a rhombus? And check out where that x is pointing. Pointing right here in the middle. So if you need to grab your sheet, grab your sheet. What is the big deal here in the middle? 90-degree angles. That's the big deal. A rhombus has perpendicular diagonals. So this 7x plus 6 is equal to 90 degrees. Little bit of algebra. Solve for x. I'm subtracting the 6. That leaves me with 84. Divide off the 7. That leaves me with an x value of 12. If x is equal to 12, it makes this 90-degree angle here at R, which forces this to be a rhombus. All right, let's check out this piece. In rhombus ABCD, D to B is 16, A to C is 12. What's the perimeter of the entire rhombus? Okay, well, I know that this is a midpoint. I know it. So if that's a midpoint, this DB16 divide by 2 gives me 8. So I've got two 8s to write in. I know that AC equal to 12, divide that by 2, and I have two 6s to write in. So what does that mean? How is that helping me? Well, there's another thing to remember. At the diagonal intersection, you have a right triangle formed. That right angle builds a right triangle. And a right triangle is something that can be solved with the Pythagorean theorem. The Pythagorean theorem, a squared plus b squared equals c squared. What are we missing? Well, the side across from the 90-degree angle is your hypotenuse, which is c. So within this picture, I've got 6 squared plus 8 squared equals x squared, the hypotenuse. 6 squared is 36. 8 squared is 64. Combine those together, I get 100. To get rid of the square on the x, I need a square root. They cancel each other out. The square root of 100 is 10. Not my answer. That's my hypotenuse. Now, what else do I know about a rhombus? How am I going to transfer that to the perimeter? I know that a rhombus has 4 equal side measures. So if I just solve for a 10 on this hypotenuse, that is a 10 for each hypotenuse in this picture. And 10 plus 10 plus 10 plus 10 gives me a perimeter of 40. Man, we used a ton of different facts there. That is a high-level question. It uses a lot of previous understanding along with this visual shape. The two key pieces, the middle is a midpoint, and the intersection makes a 90-degree angle, building a right triangle. All right, let's see what else we have here. Parallelogram ABCD is a rhombus. Angle EBC is 36 degrees. What is angle DAE? Put my X there. Okay, if your brain is not thinking about this middle intersection yet, then you really don't get it, and you need to get it. These are perpendicular. They connect at a 90-degree angle. So when it says the word rhombus, you've got to be thinking of that 90-degree intersection there. How does that help me? Well, there's 180 degrees in a triangle. We've used up 90 on the intersection. We've used up 36 with the given piece out here. So whatever's left is my third angle within this triangle. So 180, take away 90 and take away 38, leaves me with 52 here, which just happens to be the alternate interior to what I'm trying to find. So my final answer, DAE, is equal to 52 degrees. Those alternate interior angles from the very first unit of our year are back and with a vengeance. All right, last little slice. No problem solving here. You might want a picture to look at. It says select all the properties that apply to a rhombus. All the properties that apply to a rhombus. We've highlighted the answers on the front. So if you want to flip over and just steal them from the front, that's okay. But maybe as a study tool, what you should do is sketch yourself a little rhombus the best you can. All sides equal, slanted over. Draw in some diagonals here. You know the diagonals have been so important. You know those diagonals hit at a right angle, so put that in there and see if some of this is a visual connection. Diagonals are congruent. We have one short diagonal, one long diagonal, that's a no. Diagonals bisect each other. Is this point right smack dab in the middle? Does it cut your diagonals in half? That's a yes. Opposite angles are congruent. So we're talking about this acute angle matches this acute angle, yes. This obtuse angle matches the opposite obtuse angle, that's a yes. Opposite angles are congruent. Diagonals are perpendicular. There's your 90 degrees. Hopefully when you're thinking of rhombus, you are thinking of that 90-degree connection, so that's a yes. Exactly one pair of parallel sides? Nope, we have two. We have two sets, top and bottom, left and right. Opposite sides are congruent. That's a yes. The opposite sides are congruent. It's kind of like a square that's been squished. Opposite sides are congruent. You guys make sure you get a lot of practice with these so that they seem like no big deal. Try your IXL, or if you don't like IXL, come see me. I've got plenty of paper practice for you, or we can just draw some on the board and highlight and talk about it a little bit more. Happy studying.